Students, welcome to our video lecture. In the last lecture, we have done up to sum number 90 of exercise 3.3. Now, today we will complete, students, exercise 3.3. As a revision, once again, students, I am writing the shortcut formulas. 2SC is equal to S plus S. 2CS is equal to S minus S. 2CC is equal to C plus. Minus 2SS is equal to C minus. As I told, we can apply the formula in both the ways. From product, we can go to sum and difference, and the reverse, from sum and difference, we can go to the product. When going the reverse way, we divide by 2. From product to sum and product to difference, we do not divide the sum of angle by 2 or difference of angle by 2. Now, students, today we are starting with sum number 20. So I am writing question 20 and 21. Sum number 20, LHS is equal to sine of x minus sine of 3x upon sine square x minus cos square x, and 21st also I am writing LHS is equal to cos of 4x plus cos of 3x plus cos of 2x divided by sine of 4x plus sine of 3x plus sine of 2x. Okay, students, now concentrate and try to understand what formulas we are applying. So, students, you have to be very careful and cautious while applying the appropriate formula. Now, students, first of all, I take minus sign common and write this as sine of 3x minus sine of x upon cos square x minus sine square x. Now, students, my numerator is s minus s and s minus s is 2cs. My numerator is s minus s, and students, s minus s is 2cs. So 2 cos of into sine of, and my denominator is a direct formula of cos 2x. I told you cos 2x has 4 formulas, of which the first formula is cos square x minus sine square x, second is 1 minus 2 sine square x, and third is 2 cos square x minus 1. So, the replacement for cos square x minus sine square x, students, the replacement for cos square x minus sine square x is cos 2x. This is 3x plus x by 2 and 3x minus x by 2. So this changes to twice cos of 4x by 2, so 2x sin x upon cos 2x gets cancelled, and the remaining is 2 sin sin x, and that each student's our RHS. We want the answer as 2 sin x students. That is our answer. Now, students, sum number 21. Whenever 3 terms are given, generally we take first and last one because addition of the angles by 2 gives us 3x, and 3x is the angle for the middle term. So in this type of sums, generally students, we group the first and the last one. So we write this as cos 4x plus cos 2x plus cos 3x divided by sin 4x plus sin 2x plus sin of 3x. Now students, the first bracket is c plus c, and students, c plus c is nothing but 2cc. So applying c plus c, I will get 2 cos of into cos of plus cos 3x divided by s plus s is 2sc plus sin of 3x. Now 4 plus 2 6x by 2, so 3x. 4 minus 2 2x by 2, so x. We are saying that 3x and x. So common from the numerator is twice cos 3x. Common from the numerator. So what it means? Cos x plus 1. Common from the denominator. Sorry students, I think 2 is not common. So we have to write here twice cos x plus 1. And common from the denominator is sin 3x. So bracket will twice cos x plus 1 gets cancelled. Cos of 3x upon sin of 3x is cot of 3x, and that is our RHS. We have to prove this as cot of 3x. Now students, sum number 22. Sum number 22 is a special type of sum. And students, we have to be very careful about sum number 22. We are developing the sum from the basic formula of cot x plus y. Students, this formula we have already studied. Cot of x plus y is equal to cot x cot y minus 1 upon cot y plus cot x. Sum number 22, students, that sum is given a special type of treatment. So please be careful what I am doing. Cot of 3x is written as cot of twice x plus x. And I am applying the formula of cot x plus y. So this is equal to cot 2x cot x minus 1 upon cot x plus cot of 2x. This is our x and this is our y. Now students, what we are doing is cross multiplying this. So this gives us cot 3x cot x plus cot 3x cot twice x equal to cot 2x cot x minus 1. Now students, according to the requirement, I transfer cot terms on the right, 1 on the left. So we get cot 2x cot x minus cot 3x cot x minus cot 3x cot 2x is equal to 1. So this is an exceptional sum where we have developed and proved the result based on the formula of cot x plus y. Students, this is an exceptional sum. We could have used the formulas of cot 2x and cot 3x and proved the right hand side as 1. But that traditional method, students, is very lengthy. So, sum number 22, students, is an exceptional sum. We have proved the sum in a slightly different way. Try to understand and go through the sum. Okay, students, now sum number 23. Now, students, we are doing sum number 23. It is 10 of 4x. Okay, sum number 23 LHS is n of 4x, which is written as n of 3x plus x. Now students, all of you know the formula of tan of x plus y. Let us revise, students, the formula of tan of x plus y. Tan of x plus y is equal to tan x plus tan y upon 1 minus tan x into tan y. Applying this formula, we get tan of 3x plus tan of x upon 1 minus tan of 3x into tan x. Again, we have written the formula of tan 3x, which is 3 tan x minus tan cube x upon 1 minus 3 tan square x. So applying this formula, we get, applying this formula right here, this will be 3 tan x minus tan cube x upon 1 minus 3 tan square x plus tan x upon 1 minus tan x into 3 tan x minus tan cube x upon 1 minus 3 tan square x. So in the first step, I have applied, students, the formula of tan of x plus y. In the second step, I have applied the formula of tan dx. So this was the first step, which all of you must revise and remember, and this was the second step. Now, taking 1 minus 3 tan square x as LCM, we get 3 tan x minus tan cube x plus tan x into 1 minus tan x into 3 tan square x, so 3 tan cube x LCM gets cancelled from numerator and denominator. This is multiplied with 1. So 1 minus 3 x square x minus 10x into 3 10x. So 3 10 square x plus 10x raised to 4. 3 10x plus 10x gives us 4 10x. Minus 10 cube x minus 3 10 cube x is minus 4 10 cube x upon 1 minus 6 10 square x plus 10x raised to 4. What is common from the numerator? 4 10x bracket 1 minus 10 square x according to the answer. 1 minus 6 10 square x plus 10x raised to 4. That is students our RHS. This only students we have to prove. So students, again I told trigonometry. Trigonometry is application of formulas. The more you understand, the more you apply the formulas, you will master the techniques. The more you understand, the more you apply the formulas, then you will master the concepts. Okay students, now I am doing sum number 24. Now students, I am doing sum number 24, and that is, I think we did this question or not, even though I think we have done the question. Let us do it again. Sum number 24, LHS is cos of 4x. Now students, carefully observe your RHS. We require 1 minus 8 sin square x cos square x. Our RHS is 1 minus 8 sin square x cos square x. Now this formula of cos 2x we have, which is 1 minus 2 sin square x. If the angle on the left is 2x, the angle on the right will be half. So if my angle is 4x, dear students, my next step will be 1 minus 2 sin square of 2x. Why I am tempted to apply this formula? The logic is very simple. In the answer, we want 1 minus 2 sin square 2x. Means in the answer, we want 1 minus, I mean to say 1 minus 8 sin square x cos square x. So 1 is required. So I am tempted to apply this formula. Now we have already studied the formula of sine of 2x, which is 2 sin x cos x. Further, my answer is required in terms of sine and cos. So I write this as 1 minus 2 into bracket 2 sin x cos x the whole square. This gives us 1 minus 2 into 4 sin square x cos square x. So this is 1 minus 8 sin square x cos square x, and this is your RHS. Hence, LHS is equal to RHS. The required sum, students, is proved. Now we go for sum number 25. And the left hand side given is cos of 6x. And students, the right hand side which is required, the right hand side, students, which is required is in terms of x. So from 6x we can never directly convert to x. So from 2x we can convert to x. So I can apply this formula. Cos of 6x is twice cos square 3x minus 1. Check. The concept and basic lies here. Cos of 2x is equal to 2 cos square x minus 1. So cos of 4x will be 2 cos square 2x minus 1. Cos of 6x will be twice cos square 3x minus 1. So the sum still remains in terms of only cos x. So this is 2 into cos of 3x the whole square minus 1. This is the formula which, students, we have applied. Now our next formula is the formula of cos 3x, which we already know, 43, 4 cos cube x minus 3 cos x. Because first, students, we have converted the sum from 6x to 3x. Always the angle is half. Now from 3x I have a direct formula to convert to x. So I am substituting that formula. This becomes 4 cos cube x minus 3 cos x the whole square minus 1. So this is equal to 2 into 60 cos x is to 6 minus 24 cos x is to 4 plus 9 cos square x minus 1 multiply 2. So we get 32 cos x is to 6 minus 48 cos x is to 4 plus 18 cos square x minus 1, which is our RHS. So here, students, we are supposed to understand how the interconversions takes place. So that is one of the most important basic. From 6x we first converted to 3x, and from 3x, students, we converted to x. Okay, students, having done the sums, I am going to explain one very important table for trigonometry, and that table will be very useful to students. So please, all of you, try to understand the table, trigonometric table, T table. The first column in the table is T function. The second column is domain. Third column is codomain. Fourth column is range. And last column is set of zeros. The 6 T functions under consideration are sine, cosine, tan, cosec, sec, and cot. The 6 T functions under consideration are sine, cos and tan. These are three fundamental in the reciprocal. Now all four domains are R. That you should remember. All four domains are R. So always when you sit with the table, follow this chronology. Now domain of sine and cosine functions also are. Sir would have explained why taking the exercise 3.2. Range of sine and cosine function is closed interval minus 1 to 1. Means your sine function and cosine function cannot assume a value outside this range. Set of zeros of sine function is n pi, where n belongs to z, and set of zeros of cosine function is 2n plus 1 pi by 2, where n belongs to z. Means on that unit circle at 0, pi, 2 pi, 3 pi, 4 pi, sine function or sine theta is 0, and at pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, cos function is 0. So set of zeros means those angles where the respective function has a value 0. Now tan theta is sine theta upon cos theta, and sec theta is 1 upon cos theta. So when cos theta is 0, tan and sec function are not defined. So domain of tan function is R minus set of zeros of cos, and domain of sec function is also R minus set of zeros of cos. Because when cos theta is 0, tan theta and sec theta are not defined. Same way, cot theta is cos theta upon sin theta, and cosec theta is 1 upon sin theta. So when sin theta is 0, cot and cosec are not defined. So that domain is R minus set of zeros of sine function, which we have to memorize. The range of tan and cot functions are R, and range of sec and cosec function is R minus open interval minus 1 to 1. Students, derivation of all this is beyond the scope of the book at present. Nobody is going to ask you this derivations. So at present I am not indulging in derivations, but I am explaining you how this table can be easily memorized and understood. Now when sin theta is 0, definitely tan theta will be 0. So set of zeros of sine and tan functions is same. And when cos theta is 0, definitely cot theta will be 0. So set of zeros of cos and cot are definitely same. And there is no theta where sec theta and cosec theta becomes 0. So set of zeros of cosec and sec function is null set. So this T table you have to really make before you sit on the dining table to drink your milk or tea. This T table must be daily prepared once till you are thorough with the basics of this table. This table is very useful in physics also. This table is very useful in chemistry also, and throughout your engineering this table will be very useful to you students. So this T table is a D table, decisive table. This will decide your applications on the basis of trigonometry. So I request you to thoroughly write and memorize this T table. So I think we conclude the lecture. The remaining concepts of 3.4 trigonometric equation we will do in the next lecture. Thank you, students.